Everyone, meet again, March 17th. But we're gonna do for tomorrow. Alright, let's do this. Remove duplicate letters. That one, a long time ago, 2020. Jeez. Given a string, remove duplicate letters so that every letter appears once and only once. You must make sure your result is the smallest in lexicographical order among all possible results. Smallest is a subsequence of distinct characters. So we have to remove it and sort it, right? Wait, what? Oh, subsequence. I cannot sort. I was like, I just sorted. No, that's not sorting. All right, so we need to. The question is which ones to remove, right? So I know A is unique. So the position of A is specific. Oh, A and D's are unique. Then we need to remove to make sure the remaining is the smallest. Okay. I mean, we can find the letters that are unique already. So their relative position cannot be changed. Nope. I shall get all the values, all the letters, get their indices, right? And then I'm going to go from small to large. No, because if you do that, yeah, no. We go from front, right? The first one. And then we want to see if it's unique, then there's nothing we can do, right? If it's not unique, which means it has a duplicate, then we want to know in between this and the duplicate, because we want it to be small, right? Which means if I have something smaller in between this and the duplicate, then we don't take this, right? We should discard it. For example, C, right? So we find its other C is here. So we look for, actually this is the first C, this is the last C. So we look for anything in between. If there is a letter in between who is smaller than C, like B is smaller than C, so we don't consider C. I'll look at B. So B and B look in between anything smaller, we have an A, so we don't consider. This one A is unique, so we keep it. And that's C. We say B is smaller, then we don't consider it. But then if we don't consider, D is unique. Huh. Let's consider dynamic programming. So dynamic programming is, if we have only one letter, we're good. If we have two letters, if it's both are unique, then we're good. If it's duplicate, then we take one, that's good. If it's three letters, right? Let's say the first two is already the smallest, right? The smallest unique. Now we have the new one. If this one is unique, we add it. No problem. Like this is C and B, nothing we can change. We add A is unique, nothing we can change. Now we have CBA now, right? Now we add a C. Now we add a C. we need to check, right? We add a C. So we look for, because we see we have duplicates. So we look at the previous C. Okay, we have the previous C. Then what do we say? We want this one to be the smallest. The previous is already the smallest, right? So there's nothing we can make the previous smaller. Then we add a new one. So if it's a duplicate, I either keep the new one, throw away the old one, or I keep the old one, throw away this one. So we just need to see if I throw away the previous one, which one will be smaller, right? Basically, that's what it is. We want to see which one will be smaller. Basically, it's the question, like inside, if there is anything smaller. I don't know. I keep trying. So, okay, we say something small. So now we have BAC. Okay, we have BAC because that's smaller, right? Okay, we have BAC. Now D will have to add. So now it's BACD. Now C again. Okay, so we find the C. So in between is a D. So we say, no good. Cannot. If we remove C, it's actually going to make it bigger. So we say, okay, we ignore this C. Now we have this B coming in. Now, in between this B and B, we have an A. So we say we ignore this B, but we have A, C, D, B. And the C doesn't. Oh, this one actually, it might work. Again, B, C, A. B, we have something small. So be careful. If they have something small. No. The question is, if I take this B, I throw away this B, will it be smaller? It's actually become bigger because CAB is bigger. So I'm actually going to have BCA when we go to the last one. Now, this one doesn't work. All right, this one doesn't work. It's a good test case, right? The rule doesn't work. As I do have, so like I have to throw away B, but I don't have a good, because if it's BCAB, right? If it's BCAB, it has to be BCA. It's not CAB. If we find the smallest letter and see if behind this value, if we have all unique numbers, unique letters, okay? So but how? How do we tell? Okay? So for a certain letter to the end, I can calculate how many unique letters there are. So, okay. So now I can say I pinpoint into the smallest, and we see how many there are, right? If we have enough unique letters, then all the ones before it, we can throw it away. Right? Is that what you're thinking? Yeah, let's say if we have an A, and then from A to the end, I have the total number of unique letters, right? If we have a total number of unique letters from A to the end, then that is a candidate, right? And then we'll go for the first A that can achieve this. Well, I mean, if one A can achieve it, okay, it's like first A, from left to right, the first A can achieve this. And then in front, we just throw it away. So now A is done, right? And now what we want is to find the next smallest and see within it. Okay. What if I can't? What if there's not enough? Like, so from A to the end, there's not enough letters. It's a few convoluted. Oh. what if we add to the front? Let's say we have a string is already the smallest, right? From processing from what we have. And now we add another letter to the front. Now if this letter, right, is smaller than the front, and it has a duplicate later on, well, if it's unique, then we have to add it no matter what, right? If it's not unique, and it's bigger than the remaining, then we say no, we cannot add it to the front, because if we add it to the front, that means we remove the remaining, and that is going to make the whole thing bigger. So I don't add it. It's only if it's smaller and it's in count of 4, and I remove it from the back or put it in the front. Think about this. Think about this. We'll go from right to left. So that will be C, that's unique. B, that's unique. A, that's unique. C is not unique, right? So the choice is either keep this or keep this. Now because C is larger than A, so we don't keep this. We throw it away. And that's ABC, okay? So C, B, don't keep this. D, unique, we have so it's DBC now. C, we shall keep C, so CDB, ACDB. This might be right. We'll go from right to left. Because when we go from right to left, if we have the smallest so far, and we add something to the front, then we can decide, right? Because the front, if it's smaller, then we definitely will get a small value if we add it to it. Okay. Let's try this. I could be wrong. I should not check my submission in the future to give me some pressure, because I know I solved this problem last time and it never really felt that difficult, right? The last time, but this time it's just so tough. Okay, so how do we even do this? How do we do this? Oh man, because we're gonna. Wow, I need a lot of things. I need a. It's not a deep. I call it DP. Okay. And we need a hash map to record indices. And then we say for I in range, length -1, -1, -1, right? And we say if si is not in hash map, it's unique, then dp.append si and hash map si equals I. Okay? Else, if si is in hash map, right? If it's in the hash map, then we need to compare. Because we're always adding, and then the previous one will always be a value, will not be empty. As I was thinking, when I replace, I just do the empty, right? I don't really replace, I do the empty string. So if these two are the same, right? If these two are the same, then we don't consider it. So it will never replace the one in front, right in front of it. That's what I think. because this one in here, let me think, would it be empty? I'll just do another check then. If it's not in hash map, then we do this. Then we also do this as well. Hold on, I want to change this. If it's in hash map, okay, so it appears before, then we say if it's in hash map and si is the current one is smaller than dp minus 1, the last one. If it's smaller than that, right? If it's smaller than that, then what we do is hash map si. No, I did this already. That's not here. Then dp hash map si, right? dp hash map equals to this. We set it to empty. And then dp add this and the hash map we update. So once we're done, we're gonna return dot join dp and reverse it. Okay, so that's my current solution. See, this one I can do a lot of gibberish tests. That's what I call it. Just jam your fingers onto the keyboard to produce some random stuff. Ooh, that is not correct. Ooh, none of this is correct. All right, this is a serious issue. Oh yeah, that is not right. Come on, man. Come on. So now we're thinking about we will fill. Fill, turn to. Okay, so this is what we're talking about, right? So if si is in hash map and si is smaller than dpi plus 1, right? Because we go si is the current one and it's dpi plus 1. And then if that's the case, then we set this to empty string and then not append. So it's dpi will equal to si and hash map. Okay, how about this? What the heck? If si not in hash map, so dpi. Oh, for one thing, we don't do this, so we just do this. That's even more wrong. Alright, hold on. Alright, so we have BC, ABC, right? And then we have our DP is the same. So I is the last position. So if SI in the Hash map, no, it's not a hash map. So dpi equals si, and hash map. So hash map has c, position is 0, 1, 2, 3, 4, 3, 4. Okay. So next one, if si hash map, which is b, is not a hash map, so dpi equals si, so b, and b become 3, and a become 2, and now c comes back, right? C comes back. Si is in hash map. So now I is equal to 1. Okay. And now I say if, oh, I don't know what I was doing, man. Alright, so if in hash map, in hash map, I would say if this, else, continue. That's correct. And I just realized one thing. I don't need to have a DP, right? I don't need to have a DP. We'll just do S. This one. Don't need this. We join S. Ooh, that's fine. S equals list S. Oh, okay. I see what the point, what the problem is. We have to use a DP. This is okay. All right, that's what I'm talking about. We do the keyboard smashing. Eee. Try it. Okay, this one is something I can try. HKMPFWJ. All right, so let's print DP. when B happens, okay, B, E, F, K, W, J. H and F is our. Ah, I see. I do F, H, B, but because H is actually going to be replaced later on, so F is actually in front of B. Therefore, this F shall be removed. So yeah, now we're back to square one. H is smaller than B. The reason I don't get rid of H is because at this moment I don't know H is duplicate, but I can know, right? I can know that H is a duplicate. If I know H is a duplicate, then what would I do? I know H is a duplicate, right? I know H has a duplicate in front. So a choice can be, if I keep the H here, and I don't do the H in the front. do H, we have a result. If I don't do H, we have another result. What if I treat this like a graph? Each letters. Okay. Each letter has its position. Then, I don't know, from the first letter, I pick. So the duplicates have multiple values, right? I have multiple values, multiple values, multiple values. So what do? I can pick one. And once I pick one, the other two will be eliminated. Right? The other two will be eliminated. What is the smallest? Let's say from the start to an index. Okay, say from index to the end. Doesn't matter. Yeah, like we say to index from index to the end, given the current state of the letters that have been picked already. Okay, so the letters have been picked already. And will be initial state will be 0, and then index will be 0. Right, and then along the way, we can pick different letters. And then we say, I don't know, we can call whatever I've picked already, and then I have remaining, and I find out. Let's say we find out the smallest of this. Which means, as we go, one by one, if we hit one, right? If we hit one, then the choice is either I pick it or I don't pick it. If I pick this, then we have a remaining, and I'll return somebody. What are you saying? What I'm saying is, we're going to sit here, right? So H, we know it is now unique. So I can either pick this one or not pick this one. So if I pick this one, then the state just say this one's picked. Then we need to find the smallest of this, which makes sense. If I don't pick this, then we need to find the smallest of this. Okay? So what I'm saying is, Yeah, we're gonna say dp. State, this is gonna be an integer, and index is gonna be an integer, and this is gonna return an str, right? And then I do think this one we can say for func tools value cache. Right? So given the current state, right, and then we look at my current index, right, which is the index at the end. So we say, well, I mean, if index is the last one, right, so n equals len s. Say if index is equal to n, return empty string, right? Otherwise, we can decide whether to pick the index or not. Well, that depends, right? That depends if the index has been picked or not. So I just want to know if they have duplicates. But that adding another thing to the cache. But it's static. I don't know, maybe I can, maybe I can't. I just want a counter, right? That's what we want. And then we say if counter s index is equal to 1, right? Then we return s index plus dp state, same state. Ooh, the state should be this one, be picked. State or 1 left shift ord s index minus 97. I believe that's the lowercase, yeah. There's a new state because this one I got picked, right? And the index plus 1. And there's no comparison, just directly. If it's equal to 1. Else, it's more than 1, then I have a choice, right? So you need to be, say, return s index. Well, actually, return the minimum of either s index plus this thing. Just pick the current one. Or dp state index plus 1. I don't pick the current one. Now, of course, there's another thing. If counter is 1, then we definitely have to do this only once. Otherwise, if actually if it's been picked before, right, then we cannot do. If it's not picked, then we can do, right? So there's another choice. We say if, let's do shift shall equal to board this. Shoot. Right, this is a shift. I'll just say left shift. So we say, what do we say? We say if state right, do the right shift. Right? If the right shift is a 1, which means it has been taken already, right? Which means this one I cannot pick again. So we simply return dp state index plus 1. So this one's already taken. Otherwise, if it's not been taken, then we can make a choice. Either I still don't take it, or I do this. But the thing is, if it's taken, I can do this. If it's not taken, then I have two options, right? So this is I have duplicates, and it has not been taken, so I have two options. Option 1, yeah, I'm gonna say option 1 is equal to this, right? And option 2 is equal to this. Okay. So we also have the res length has to be len counter, right? Oh, you actually don't know. Huh. Well, that means it has to be taken. Because it could be I just don't take it again. So once I take it, it will I don't know. Can I just say the two should be same size? Because they have the same state, right? So they should be the same size, which means if we say len op1 is larger than len op2, right? Then we return op1. If len op1, I can go elif is smaller than len op2. Then we return op2, right? And else, so then now they're the same size. So if they're the same size, I'm comfortable to say do op1 and op2. Okay, I get call dp. State initially is 0, right? And index is 0. I want to return this thing. I don't know. Yeah, it's not right. This is not wrong. This is not wrong. This is also not wrong. This just means I have already taken current one. I already taken it, so I cannot take it again. And this is just, I will take the current one, set it up as if it's been taken, and we try the next one. This is if I don't take the current one, theoretically going to write the remaining. Maybe we should also, like, if it's the last one, Okay, so it's not going to be a counter. And say for okay, and then these are all fine. Here is the issue. If it's not taken before, then I can definitely take it. And whether I can choose to not take it, it depends, right? Let's say if, right, s index and hash map the last one is not equal to, right? If it's not equal to the current index, which means there is still hope, right? So we say hash map, actually this be len hash map, right? Len hash map is equal to 1, right? Then we have to do it. So this is saying if the last one, these two can be combined. If the last one equals, then we have to do this. Okay, so we say if this is equal to the index, right? That means I'm the last choice. Then option 1 has to be this. We have to take it. Right? And then else is not. Then we can do an option 2, which is we don't take it. Right? Option 2, hold on. Hold on. This is to say whether we must take the current one, right? So if it's equal to index, then we have to take the current one, right? We have to. Basically, if this, then we have to. So if this, we have to return this, which we don't have to do this one anymore. Right? It's like we must take the current letter. Else it's not. Then we have two options. Right? Then we have two options. Then we basically say we return the minimum of the option. Let's say this is I don't take it, or this I take it. Huh. It's even worse. It's even worse. How? All right, let's see. 0, 0 coming in, right? So I have the shift, and we check, it's a 0. And we check, it's not. So the first level, I'll say C can do. So I do, yeah, because the hash map C is not the last one. Then we do either C, and then plus DP. Basically, we're going to do the BACD CBC. Or I do the whole thing, right? So we do BACD CDC. And I take B, and do A, and then we'll do A, and do this. C can now do, and we'll do D. And then C can now do, B can now do, C can now do. Yeah. Or BA this thing. What happened to the D? No, the B. Did we go to the B? Oh my god. I want a simpler one. This one's simple enough. So A. And what we find out is, yeah, let's also do the hash map. Kind of just print out the hash map. Make sure the hash map is horizontal. print hash. Okay. So we're at A, right? So A comes in, shift will be 0, and state 0 as no. Okay, so in a hash map, A minus 1 is 0 equal to 0 current. So it has to be A plus dp, the next one. Okay, so now we do dp cd cb. Okay, that's the current dp. And then we do again index c. It has not been set, but hold on. We're at 1, right? We're at index is at 1, and 1 is not equal to the hash map at the end. So I have two choices. So we either do C, and then we consider DCB, or we don't do C. We consider DCB, right? So in the case I have C, now we can say DCB. D we have to add, so this one, D definitely add. Then we consider CB in this case, right? CB. In this case, CB, C is not going to, because C already has, so we're just going to consider B by itself. Alright, we'll consider B by itself. And B, then we shall return B plus empty. So this one shall return B. How come B is not returned? Yeah, I mean, if I keep struggling like this, I will have to run a debugger. Usually print shall work, but C, D, and D. That's the split. We have C, right? That's when we have a C. So either C, D, or D. What happened to B? Wait, is this one reached? Yeah, it does reach. Yeah, B is reached. No, B is not reached here. Wait, hold on, why? B is not reached here. That's strange. B is reached here. how did B reach here? Okay. Let's print state. Well, actually binary state. Index. I don't know which part is wrong. Yeah, 97 is not right. Oh, this is not wrong. Maybe the shift? Oh. Your bit mask, there's a bit mask skill is kind of poor. Alright, this one seems promising now. In this case, I only need to obtain the last one. So I don't have to be a default dict. It just needs to be a dictionary. Which, honestly, we can just say... Oh, I just default dict int. Oof, int. Yes, we want the maximum, so... no, because we are iterating through, so we just say this one equal to I. Right? Then why don't we just do it this way? Right? It's just going to be letter and I. And then we just do if this is equal to. Yep. Try this one. Yeah, these are going to pass. Ooh. I feel like it's going to time out. I don't run it. It is correct, but I feel like it's going to time out. Yeah, it's only 40. Nope. Nope. Wow, how did I solve it? Memory. Ah. Alright, this one is... There gotta be a... Do I have a hint? I can do this. However, like I figured out last time, we just... Alright, ready to see the hint? It's been an hour, so we have to see the hint. Greedy. Monotonic stack. It is monotonic stack, huh? It is monotonic stack. Yeah, basically just saying I'm gonna pop. I push a smaller and I can pop something bigger if we have another one in the end. So I pop, come in, and then we cannot pop. I come in if it's smaller, then to pop is if this one can. So basically, what it's saying is stack, right? And we have this hash map. And then we say for letter I, letter in, enumerate as again, right? When enumerate as again. While stack and stack this is larger than letter and hash map. We're going to push two things into the stack. And hash map stack minus 1. 1 is the letter is larger than stack minus 1. Nah, that's a 0. 1. This means we have more than stack dot pop. Right? Once we're done, stack dot append letter and I. Oh, we also need to see if I have been taken already. Okay. Scene. Okay, stack.pop, scene.remove stack.pop 0, right? And then, oh, it also depends on whether the current can be added. Hold on, what do you mean? Yeah, if I pop, if I cannot add myself, that was the point. Like if I have been added before, and now we add something bigger, and I come again, right? I come again, and say this bigger can come later, so I pop this, and then what are you saying? It's gonna be larger than equal to. And I'll add myself. If letter not in scene, stack.append scene.add. Okay, then we say we return join um, 0 for alley in stack. Is now correct. All right, I'm gonna go back to the Huh. Like these lines I can handle. Ha! Shoot. Oh, critical thing is at the end. Alright, so maybe we delete the ones in the middle is fine. Ah! Alright. This is the one that we need to... let's work on this one. It's okay. Alright, okay, what went wrong? So, print hash map. Okay. And then, so G, J, V, F is small. But a V has appeared once, so I cannot pop a V. So I have to do F, K, M, E, U, I, N, R, I, R, N, I, N, R, I, R, N. So I did R, M, E, U. Yeah, I just imagine. And then G, I cannot pop U. And then G, U's I don't do G. And then I do I. And then I do J. J is bigger, so I do J. And then I do R is bigger. R cannot do R. Cannot do N. Cannot do N. Let's print the stack. Print this thing. EU, I, oh, J cannot do. And R, and N comes in, pop the R, K cannot do. Who get the N popped? think that is the issue. It has to be not in scene. Don't understand. There's no W. How come the W gets thrown away? Check. That the index, that the hashed index, right? If it's larger than, that means I can afford to throw it away. But what the heck? Man. Oh. Choice what? Not choice. Oh, maybe we can do choice. Yeah, I like rand int better, right? So 0 to 26. 25. And then char this 7 plus. All right. Find the test as well. YYNKE. Alright, let's try. YYNKE. So, in this case, I miss a Y. What? Alright, so for I in red, if letter is not in scene, no, so we push Y0 to it, right? And Y is seen. And Y comes again, I don't do it. N comes. Oh, I see. Oh, I know. Oh. So as we go through, we can say we consume, right? So we say we'll consume. Okay, so it'll be like this. For each letter comes in, I have to say if hash map letter is equal to I, so this is the last one, right? It's the last one. Then we set hash map letter to -1. And this indicates it's the last letter, last encounter of the letter. so no more, right? So in this case, then if this one is not in C, then in the future I cannot pop it. I don't need these answers. Okay. So you're right. That was bad. So bad. Ah, this one's so bad. So hard. The monotonic stack never occurred to me. But it makes sense, right? It makes sense. We can only pop the bigger letters on the stack if there are more. If there are more copies of it later in the string. So we use a hash map to record the latest occurrence of each letter and use a scene set to keep track of what letters have been used. The key trick is that once the last copy of a letter is encountered, the record on the hash map must be set to a very small value, such that the previous copy will not accidentally be popped. Well, this is ON, but it's very slow. 73. 18% rank. Alright, let's see the. So this was my first solution. 289 test case. Oh, that's the thing I want to do, but this one's so bad, so I kind of don't want to do the other one. Alright, let's see this one. Oh, just to pass today's challenge, not my solution. Oh, I had a trouble on this one too. All right, let's see. Well, at least I wrote it myself. I do that. I have a stack. You can do that because the longest is going to be 26, so it's fine. So, okay, so I don't need to use scene. Yeah, that's just... Wow, this one's pretty hard. Use stack as scene because the size of stack won't exceed 26. Scene is not necessary. But how do I handle the I? Yeah, well, this is larger than, so I can use larger than. And have more copies. Have more copies. Have more copies. If it's not in stack, and while stack, and this is larger than letter, and hash map this is the last occurrence of the previous one because we want to pop it. So we want to know if there's more existing. So I just need to see if this thing is larger than I. If it's larger than I, that means we have more. But if not, that just means we don't have any more after. So in this one, we just do stack.pop. Right? And then we just stack.add. We don't need this. And we just need to join stack. Yeah, we should actually use this. Try this. Oh, we can do 100. The 100. And for a while. So another crucial observation is that we can check whether a letter to be popped has more copies by comparing the current index with hash map. Right. So previously we compare the index of the letter to be popped. Right, we compare the index of the letter to, oh, this is too slow, man. This is ridiculous. All right, that's to 10. Yeah. So previously, we compare the index of the letter to be popped with the index of the last occurrence. Now this creates trouble. Right, this creates trouble when the letter inserted into the result is has a smaller index. Yeah, wait a minute, this creates trouble. No, this is wrong, right? This is wrong, and we have to do we're going to create an extra step for last encounter of the letter to correct it. Now in this method, we simply compare the last occurrence index with the current index. If the last occurrence index is larger than the current index, then for sure, right? Then for sure there are more copies. Otherwise, it's the same. This is pretty hard. All right, what is this? We always pick the smallest. That's the index. So we find the index of this letter towards the end. It's a new S, next S. If set next S equals it just means the next S has the same, right, to S. If that's the case, then we can take this letter, yeah, which means we can, yeah, this is the next, it's like after I take this letter, what's the remaining? The remaining is the same, right, including the current letter. So this is the same as the original, which means the ones I discarded does not affect. So I can always take the smallest and plus the remaining. If it's not the same, set this is not the same, which means if I take this letter, so the letter will, then this is not the same. That just means I cannot take the current letter. Yeah, I think I'll stick with this one. All right, that will be it. Wow, this one is pretty bad. All right, see you guys tomorrow. Adios.